class. Today we're going to be talking about finding equations of lines. When you try to find an equation of a line, the form of a line that you use is called the point-slope form. It's called the point-slope form because you actually plug in a point. Notice the x1 and the y1. The subscript 1 is signifying that that's one of the points that you might be given. You'll be given at least 1 point in the problem when you're asked to find the equation of a line. Notice that the m is also here. You'll also be given the slope, or you'll be given 2 points, which will make it so that it's possible to find a slope. So in this form, you'll be plugging in a point, which will replace this x1 and the y1, and the m here will also be replaced. Notice that I also have a y that's in red and an x that's in red. Equations of lines do have an x and a y in them. And these two red variables, the x and the y, are the variables that will be in the final answer that is the equation of the line. And I've put them in red so that you can think of them as being hot. And when things are hot, you don't want to touch them. So don't touch these and don't replace them with anything when you're plugging values into this form of the line. Now, you can use this form in the way it is right here, or in almost every single instance, you are going to be taking this form, plugging values in for the y1, the x1, and the m, and then you're going to be solving for y. Well, if that's the case, another way that this form of the line is written is with this y already by itself. If you use this form with the y already by itself, this y1 is moved to the other side. And since it's a negative y1, that's done by adding y1 to both sides. So an alternative form of this equation would be with y by itself, and on the other side you have m times x minus x1 plus y1. You can use either form of the line. I prefer this form because all I have to do is distribute and combine like terms. This form here is also fine. This is what you'll see in your book. You'll just end up having to add y1 to each side both times, or every time you use it, and then simplify. So it's up to you which one you want to use. So let's go ahead and use this formula, and let's say that you were asked to find the equation of the line with slope equal to 2/3 through the point 6,1. Now, the key that's telling you to use this form of the line is that the directions say find the equation of the line. Anytime you see that, you're going to be using this equation. Now, it says that our slope here is 2/3. That means we're going to replace this m here with 2/3. It also gives you a point here. That point is going to be your x1 and your y1. So this x1 is going to be replaced with 6, and the y1 is going to be replaced with 1. What we end up with is y equals 2/3 times x minus 6 plus 1. Now all we have to do is distribute our 2/3, and we get y equals 2/3 x, and then 2/3 times this is -4 plus 1. Combine the -4 and the 1, and you end up with y equals 2/3 x minus 3. And this is your equation of your line in slope-intercept form. Now, let's go ahead and do another problem where maybe you're not necessarily given the slope and you need to find the slope in order to complete the problem. So let's say you're told find the equation of the line through the points 1, 4, and 2, 6. Notice that there's no slope, but yes, our point slope formula requires a slope. Because we have 2 points, we can actually use our slope formula to find the slope. So on this, you're first going to use the slope formula, which was y2 minus y1 over x2 minus x1. And then after we use that, then we're going to use our point slope formula. And how about if this time we use the other form of it, which is y minus y1 equals m times x minus x1. So you can see both ways used. So let's go ahead and first use our slope formula to get a slope. And we first need to determine which point's going to be the first one, which is going to be the second. So let's label this x1, y1, and this one x2, y2. In our formula, the y2 will get replaced with the 6, and the y1 will get replaced with the 4. The x2 will get replaced with the 2, and the x1 will get replaced with the 1. That gives us 2 over 1, which is a slope of 2. That means in this formula, the m will get replaced with a 2. Now, for the x1 and the y1, it doesn't matter which point you use. Both of these 2 points will give you the same answer. I'm just going to go ahead and use the 0.14, but you could use the 2, 6 to plug in for the y1 and the x1 here and here, and you'd get the same answer. So if I use 1, 4, this y1 is going to turn into a 4, and this x1 is going to turn into a 1. That gives me y minus 4 equals 2 times x minus 1. Now we distribute, and we get 2x minus 2. Then we need to go ahead and move the 4 over, so we're going to add 4 to both sides. Those cancel, and the final answer is y equals 2x plus 2. So that's how you would deal with a problem where you're not actually given the slope and you need to find the slope and then use it in the formula.